class 10 mathematics in the chapter which is going on is triangles. In that exercise 6.3, in this video you can start from the question number 4. In question number 4, the diagram given here is this one. Triangle TQR where P is a point on the side TQ and S is a point on the side QR. And PS is joined and PR is also joined. This angle they named it as angle 1. This angle is named as angle 1 and this is named as angle 2. Nothing, the ratio of the sides given to us in this way QR by QS or Q equals to QT upon PR and angle 1 equals to angle 2. These two are given us. They are asking us to prove that triangle PQS is similar to triangle TQR. These two angles are given. In solving this, we need to use the given things. The given thing is for the ratio of the sides given and as well as one angle of the one triangle is equal to other angle, that is angle 1 equals to angle 2. They are asking us to prove the triangle PQS is similar to triangle TQR. We need to observe this figure carefully in order to prove the required one. In proof, this is the two triangles PQS and TQR. If I redraw this figure in a different form, I'll draw it. It's in a cross diagram, so I'm making it as a straight one. If this Q, if I take here this Q and this is TR, and this QT we have a point P. On this QT we have a point P, whereas on this QR you have a point S. And this PS is joined, and in the set Q I have this as angle 1, and at R if this I join here, this angle is given as angle 2 for us. The ratio of the sides here you see QR by QS. In this side if you see QR by QS, on this side what we have QT by PR. This QT by PR is given. Instead of that, if I have QP, here if you see this QR by QS is given as a ratio of this side QR by the point S, whereas the other side on QT, it should be QT by PQ, but here it has QT by PR. In both the triangles, whereas if you see this QR or QT, the sides QR by QS, that is equals to QT by PR is given. Instead of this PR, if we have this PQ, the angle Q will become common, so that we can apply side angle side similarity rule to see that the triangles are similar to each other. So the problem is with this PR. Instead of this PR, if I have this PQ, this side QR and QT will be in the same ratio by PS. So in order to find this PR, I first aim to use this angle 1 equals to angle 2 that is given. In order to prove that angle 1 and angle 2, first we need to identify that these two angles are present in which triangle, or we need to think that do we have a triangle in which these two angles are present. Are you able to identify in which triangle these two angles are there? Angle 1 should be there and angle 2 should be there. I think this PQR triangle. In PQR triangle we have angle 1 and as well as angle 2. For our convenience, if I draw a small figure of this PQR triangle, PQR, if I take in this way, angle P and PQR, where at this point has angle 1, where I here at R I have here angle 2. That means in this triangle, angle 1 and angle 2. These two angles and these two angles are equal. In 9th class, you learned the properties of similar triangles or isosceles triangle. In that, you know that angles are this. Angles opposite to equal sides are equal. Sides opposite to equal angles are equal. I will use here. Sides opposite to equal angles are equal. Here in this triangle PQR, angle 1 equals to angle 2. So the sides opposite to these angles are also equal. If I mention that here in triangle PQR, sides opposite to these angles are what? PR. Angle side opposite to angle 2 is what? PQ. So that I will write as PR equals to PQ. How I am writing this? Sides opposite to equal angles. Since these two are the sides opposite to equal angles, those two sides are also equal. If I put this PQ in place of this PR, how this ratio changes, you see. I'll write it as separately. In order to make some space, I'll remove this. I'll write here. Here in place of this PR, we take this as equation 1. I'll put that here in place of PR, I can write it as PQ so that it becomes, and this what is given to us, that I will take, put 2 in 1. That means equation 2 is what? PR equals to PQ. If I put that in equation 1, in place of PR I have to write it as PQ. So that this changes as QR by QS is equals to QT by PR. In place of PR I write this as PQ. In triangle PQS, this is the triangle in this figure, triangle P, which is our RTP. PQS is similar to TQR. See here, if I draw a darker diagram here, this is triangle PQS, in which we have, that is PQS, and the other triangle is what? TQR, which we need. Or if I draw other figure in order to prove, which I have to prove as an RTP, that two triangles I am coming to them now first. Here, triangle PQS. If I draw here triangle, I take this as P and this as S, and here I have angle 1 PQS, and the other one is triangle TQR. TQR. This as T, this as Q, and this as R. If I take at this Q, I have again angle 1, or it is a common angle. So one angle of this triangle in which our RTP is there, one angle of this triangle is equals to one angle of the other triangle. To use this ratio. So in order to prove that ratio, I'll take this TQR triangle. And if the first diagram which I have erased, again I am drawing here. This is Q, if I take, and this is T, and this is R. On QT I have a point P, and on QR I have a point S. We have joined it here. The ratio you see, QS by, sorry, QR by QS. QR by QS for this side, which I told in the beginning of the numerical. Whereas on the other side now I have QT by PQ. This you see, QT by PQ. That means this side and this side are in the same ratio. Sides are in the same ratio, and the common angle is angle Q. The angle Q is present in this triangle, and as well as angle Q is present in this triangle, and the sides are in the same ratio. The one angle of this triangle is equal to one angle of this triangle, and the ratio, the sides including these two angles are in the same ratio. That is, you see, QR by QS, and this side is QT by PQ. The sides are divided in the same ratio, and the angle including those two sides are proportional. So we can apply here side angle side similarity rule to say that these two triangles are similar. This, alright, in triangle, which we need to prove that too. In triangle PQS and triangle TQR, we have angle Q equals to angle Q, that is a common angle in both the triangles, and even we have QR by QS is equals to QT by PQ. Sides and one angle equal, and the sides including those angles are proportional. So therefore we can say that triangle PQ, this ratio QR by QS, and here on this side QT by PQ. So this side and this side are in the same ratio, and this angle is equal. Angle Q, the sides including are QR and QT, which are in the same ratio. So it's a triangle PQS is similar to triangle TQR by side angle side similarity rule, which is our RTP. So hence prove. In the beginning, it may be a little confusing. You draw the figures again and again. We carefully observe, then definitely it will be applying the side angle side. From the beginning, I want to use this. I have seen the ratio. Here I have QR by QS, but this side it's a problem. Here it is given something else as a PR. So by using that isosceles triangle properties, requires angle 1 equals to angle 2. I got that PR equals to PQ and I have put that in this. So the ratio changed in this way and the angle Q is common. So there I have applied side angle side similarity rule, and in order to prove that the two triangles are similar.